All right, and welcome to absolute value inequalities, level 1. Oh, I should have written that. Level 1. Okay, so for number 1, it says solve for the values of x and graph the solution set on the number line. Okay, well, the first thing we always have to do when it comes to absolute value inequalities is identify what is the symbol and what does the symbol mean. So in this case, when we see the less than symbol, by the way, I read this from left to right. This is the direction that my eyes read it. And notice that the first thing we hit is the smaller side. So you can kind of think of this as saying, hey, this is smaller than, or AKA, this is what we call less than. Because I still have some students who are a little unsure of how to read these. So we read them from left to right. And if we hit the smaller side first, it's smaller than, or less than. Now, these are going to be our and statements. These are going to be our and statements. And there's two other ways you can think of it. You can think of it as either inside, or you can think of it as in between. And I'll explain that a little bit better in just a second. So, what's going to be our rule for when we do this? Well, since we're saying it's inside or in between, we take whatever is inside our absolute value, our 2x plus 4, and we're going to put it inside less than symbols. All right, because this is less than, we're going to put it in beside two less than symbols. Now, one thing that we have to remember is that when we take away our absolute value bars, whatever is on the right, in this case the 8, has to become plus or minus 8. And it only makes sense for us to say the negative 8 is on the left and the positive 8 is on the right. Now from here, we can simply solve for x. Let me go ahead and write this off to the side. We'll say, okay, we have negative 8 is less than 2x plus 4 is less than 8. And from here, the first thing we want to do is ask ourselves, how can I get this x by itself? Well, do I get rid of my multiplication or do I get rid of my addition first? What do you think? And of course, if you said we get rid of our addition first, you are correct. We'll subtract 4 from every single place. We'll subtract it from the middle, we'll subtract it from the left, and we'll subtract it from the right. And negative 8 minus 4 is negative 12. Is less than 2x, is less than, because we have a 0 pair, 8 minus 4, which is 4. Now from here, how do we get rid of this 2? Well, we are going to divide everywhere by 2. And negative 12 divided by 2 is negative 6, is less than x, is less than 4 divided by 2 is 2. Now what do? We come over here to our number line, and we can say, you know what? Our negative 6 is on the left, our positive 2 is on the right, and we then want to circle our tick marks, and we ask, okay, is negative 6 included in this solution? We're saying that negative 6 is less than x. Well, since it's not a less than or equal to symbol, we leave it open. Okay, we'll leave both of them open. And since x is essentially in between negative 6 and 2, we're just going to say, hey, we're going to shade everything in between these two or inside our solutions. So if I were to say, hey, what are some examples of some solutions? You might say, let's see here, you could say negative 5, comma. We know 0 is in here. Okay, we could even say 1. Yeah, 1's right there. That's a solution. So all of those check out. And if I were to say, well, what's something that's not a solution? You might say, you know, way over here, 8. 8's not inside our shaded region. If we go even further, we could say, you know what, 1,000 is not inside our shaded region. And if you wanted to get real fancy, you could even say negative 6 and positive 2. Okay? So anything in between those is a solution, but those two numbers and everything on the outside is not a solution. All right, let's move on to example number 2. Okay, here we have example number 2. Solve for the values of x and graph the solution set on the number line. Well, notice again we have our less than symbol, so that's going to be our and statement. We could say and, or it's on the inside, or we could say it's in between. Any of one of those would work. And let's see, if that's the case, well, we would say, okay, this negative 3x minus 9 must be in between our less than symbols. And wait a second, remember when we get rid of our absolute value bars, what do we always do to our constant? We make it positive or negative. So let's say negative 6 is less than negative 3x minus 9 is less than positive 6. Let's go ahead and write this off to the side. Okie doke. So it's in between our inequalities, and we ask ourselves, well, what do I get rid of first? My multiplication or my subtraction? Remember, we always get rid of addition or subtraction first, so we can add 9 on all three places, in the middle and on the left and on the right, and negative 6 plus 9 will give us 3, is less than negative 3x is less than 6 plus 9 would be 15. Now from here, I want y'all to remember, when two things are side by side, they're being multiplied, and the opposite of multiplication is division. So we can divide everything here by negative 3. And what I really cannot stress enough is that after we do 3 divided by negative 3, which is negative 1, we say, well, wait a second. Whenever I divide by a negative, what happens to my inequality? My inequality has to flip from less than to greater than. So we say negative 1 is greater than x, which must be greater than 15 divided by negative 3 is negative 5. Now, notice that negative 5 is actually the smallest number. Because we always want to order things from smallest to largest in math, let's take everything we see here and we're just going to completely flip everything. And so I'll move my negative 5 all the way to the left, and if I flip everything, this inequality flips to become a less than, my x flips, and this greater than flips to become a less than, and my negative 1 is now over here. And now we can actually order this correctly on the number line. So I'll say, okay, we have a negative 5, we have a negative 1, and circle both of these. And let's see, since our x, we're saying negative 5 is less than x, is less than negative 1, we're talking about every solution on the inside. So if I were to pick any number here, like negative 3, well, I know that that is a solution. But if I were to pick negative 1, I know that that's not a solution. Or I could even say like something like positive 3, well, that would be not a solution as well. All right? I'll see y'all in our level 2 video.